Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Securing Sensitive Data in Enterprise Environments using IBM Optim Data Privacy Solution. Our guest speaker today is Mr. Girish Sundaram, Technical Solution Architect at IBM India Software Labs. Girish Sundaram is a Technical Solution Architect with the IBM India Software Labs and works closely with various strategic global IBM accounts for implementing mission-critical business solutions across various domains. He has wide-ranging deep product expertise including multiple database technologies, InfoSphere Optim Enterprise Data Management Solution Suite, data warehousing and ETL development. He is an accomplished inventor with a number of filed patents, published disclosures, and has a rich expertise in research publications in renowned international journals. So without further delay, I introduce you all to our guest speaker. Over to you, Mr. Girish.
Hi. Good afternoon, everyone, and welcome to this presentation. The way this presentation has been organized is that the first 1 hour we will be discussing about the various facets of data privacy and specifically about IBM Optim Data Privacy Solution. And the last 15 minutes will be dedicated to a Q&A session where we will try to answer whatever questions are possible within the duration. Why is data privacy a high priority? Because data privacy is no longer optional. Now it is mandatory by law. It has become a regulation in many countries, including India. So data privacy is no longer a good-to-have feature or a good-to-have option for enterprise. It's mandatory by law. And data privacy is not specific to any country or any specific region. It's a global phenomenon, especially with a lot of developed countries, and many developing countries have already implemented regulations. They have passed bills in the parliament, which makes it mandatory for them to implement, which makes it mandatory for all the enterprises in that particular country to implement data privacy compliance. And they can do it in a variety of ways, which we'll be discussing it in the next few slides. Data privacy compliance affects the business, right? And many of the data breaches which has been observed is basically from internal weaknesses. Many of the companies have got culprits within their own organizations. Examples of such internal weaknesses can be employee misuse the payment card, payment credit card numbers, which contain sensitive information. Right? Most often, you use your within your own company or within your own. An example might be a person is traveling on a business travel, right? And he's sharing his corporate credit card number with his IBM or any other organization's travel team. Okay, so the travel team employee will have access to the employee's credit card information, which can be misused potentially. Okay. Another example of an internal weakness is an employee, when he's part of an organization, will have access to a lot of confidential data, which he is storing in his own laptop, and he can even share it or store it in an external hard disk. And even if he is not an employee of the organization, if he resigns from the organization, the data is still there at his personal level and can be potentially misused. Especially India becoming an outsourcing destination. It has always been a favorite outsourcing destination for many years now. We have had a lot of compliance problems wherein we had, we had a recent case wherein a bank employee was found misusing a person's credit card information. Okay, so stakes are pretty high, and there are a lot of issues which come when data privacy is not strictly enforced. Okay. So what if companies do not take steps to protect sensitive information? Right. So what happens in this kind of a scenario? So as an enterprise, you risk losing customers, you risk losing revenues, and you even risk going out of business. Okay. There was a study done by Onimon Institute which suggests that 35% of the customers will stop doing business with the company after a single privacy breach. Right? Imagine someone, a potential customer comes to know that if I store my hard-earned cash in a bank, and if I'm using a credit card company of a particular bank, it has been previously, some bank employee had misused the cash or had done some misappropriation using the credit card number, then it definitely would affect the business, right? A customer would not be wanting to have a credit card with that particular bank. So you do definitely have a potential risk of losing business. And when the same kind of occurrence of data privacy breach happens multiple times, the number of potential data loss or potential risk of business loss goes up to 45%. So that's significant. And data, as we know in an enterprise, can be existing in production environment, and most often than not, data is also existing in non-production environments, right? Many of the production systems nowadays, and even previously, always had very good security measures, wherein there were physical security, where you cannot really enter a data center unless you have authorized IDs. And even when you log in, when you enter the data center, you cannot access a particular production database unless you have got the credentials at the system level, right? So production databases or production data do have a lot of controls and a lot of security measures, but many of the non-production systems do not have such measures, and they are easily accessible to almost everyone in an enterprise. And it has been observed that data, due to a variety of reasons, it can be because of a flaw in an internal system, or it can even be done knowingly. Data from the production system, in many cases, are found to be existing in a non-production environment. It can be a testing environment or a QA environment, and this information is exactly the same as it is existing in a production system. Now, assuming that this is sensitive data, it can be really dangerous and can be potentially misused. Okay. What do you mean by sensitive data, right? And US and in India, you also will be having, sometime in the future, we would be having a number which can be used to uniquely identify a particular individual. Other examples include a PAN card number or the name coupled with an address would make it very easy to identify a particular entity. Okay. What is the solution? If we have, and now we know there is a problem of data privacy breach. So what's the solution? Solution is to have an option of de-identifying sensitive data or sanitizing sensitive data. Okay. Now, when we say de-identification, it basically means a process to systematically remove, mask, or transform data elements that could be used to identify an individual. Right? So it can be done in a variety of ways. There are a number of options available wherein you can de-identify sensitive data. Now, the definition of personal identification information might differ from organization to organization, but generally, anything which can be used to potentially identify an entity or an individual is classified as PII. Okay. And other requirement is that in many cases, the non-production systems, as in a test or a QA environment, would be requiring production-like data. They don't really need production data. Okay, so for a developer or a tester or a trainer to work on de-identified data, while we should ensure that there is no data privacy breach, we should also at the same time ensure that the testing and the QA team is not affected by the de-identification process that is followed. Okay. An example that is shown in the slide here is that we have a credit card number which is having a specific look and feel. Once it is de-identified, you see that the numbers are changed, but the look and feel still remains the same, as in the number of digits in the credit card number, potentially even the starting two digits or the last two digits, all this can be changed so that even if the look and feel is the same, the actual data cannot be misused. So, and what if the data is stolen, exposed, or locked? So, if you have de-identified the production data or sensitive data, and that data is made available for general use, and someone tries to misuse it, you cannot do anything about it. You cannot do anything with that. The simple reason is that the data is now masked or it is transformed beyond, beyond potential misuse. So no one can probably misuse that data. So companies need data privacy solutions that provides a comprehensive data masking technique, support for application logic, support for business context data elements, and should have capabilities that preserve data integrity. Okay, so enterprises have got option of doing it manually using their own custom code, or they can also go in for industry standard data privacy solution like IBM Optim, which has got all these features of comprehensive data masking techniques, support for application logic, support for business context data elements, capabilities to preserve data integrity. You would see what exactly these mean in the next few slides. Application-aware data masking. It's not just enough to mask or transform the data. Okay? The requirement from a solution should be that we should be able to understand what exactly the underlying application requires and how it is working with a specific portion of the data or the entire business object, and how, if after masking it, would be useful to the testing and the QA team. At the same time, it should not break the application logic, right? Examples of masking techniques include string lib fill, substring, sequential random shuffle, concatenate masking techniques, and Optim also has got what we call as key propagation. So we'd see the meaning of key propagation and its benefits and the requirements why we should have key propagation in the next few slides. Optim also has got a feature wherein it ensures that masked data is propagated consistently throughout the test database. It's not as if you mask data in one single data data table, but when I modify a specific column in a table, I should ensure that the related fields, as a result of referential integrity, is propagated across through all the remaining elements which are linked to that to the primary element or the primary table. And it should not just propagate it, but also ensure that it is consistently propagating and masking the data elements. Okay. Context-aware data masking. Optim Data Privacy Solution has got support for context-aware data masking, wherein we have data privacy solution for a variety of prepackaged applications like ERP solutions like SAP, PeopleSoft, JD Edwards, and all these are prepackaged custom applications. Right? So the definition of business objects within these prepackaged solutions are understood by default by Optim, and it will ensure that when you mask a particular portion of the data, it is seamlessly propagated across all the related business elements. Optim has got what is called as the Optim Transformation Library, which has got a huge repository of credit card numbers, social security numbers, email addresses, first names and last names, and these are specific to, I mean, you can even customize it to particular credit card companies. Like, for example, you have got credit card numbers specifically for Amex, for American Express, for Master, for Visa. So all these can be customized and can be privatized for a specific usage. It's also got support for a large number of built-in lookup tables, which can be used to mask the first name, the last name, the zip code, the street, basically the address. All these can be masked using the lookup tables. Persistent data masking. Okay, this is another requirement of a robust solution, which and Optim has got a feature of a persistent data masking, which means that if there are two different tables or there are two different database repositories, and I'm using Optim data privacy solution to mask the same data element, Optim will ensure that the same data is always masked and the end result is always the same, which means that it's basically following a persistent data masking technology or a method. If I'm having the same data which has to be masked, and if the solution is giving me two different output during two different runs, it's not really persistent. Okay, and that can really break up the application logic, and that's not going to be useful for your testing and QA teams. So persistent data masking using data privacy solution is a primary requirement of a robust solution. Managing relational data typical. This is how a typical testing and a QA environment would work. You create a modified application and you copy production data for testing. You privatize personal information, and this is now mandatory. And you inspect and add data to test error routines. Then you go and test, do the actual test and the QA processes, and you compare the before and after data. You ensure that before you compare the before and after data and see what kind of differences have been made, and you have an option of going and refreshing test data. And if you are satisfied with the test process, you go and deploy that in production system. Okay. Managing relational data using Optim. In the previous slide, we have seen that how it is done typically in an organization where you don't have a solution in place, wherein people are using custom solutions or they are using inbuilt scripts or custom developed scripts. In the same place, if you're having Optim, it's going to make life much more simpler for all the people involved, especially audit consultants, security consultants, and also the testing and the QA team. You have got you can use specific features of Optim privacy solution in various stages of the of managing relational data. You can use Optim migration facility when you're copying data for production, and you can use it to even privatize the personal data using the migration facility. You can inspect and add data routines using the Optim edit facility, and the compare, which is again a very tedious task if you're doing it manually or using any custom scripts. I can easily compare the before and after data using the Optim comparison facility. It gives me a detailed report of what exactly has changed. It highlights and classifies information based upon the changes. Okay. And for archiving old data, I can use the Optim archive facility, which is part of the Optim data growth solution. So TDM stands for test data management. So data privacy goes hand in hand with test data management. In many cases, we suggest that the test data management solution is, goes hand in hand with data privacy, so that we ensure that the testing data is privatized and it has got the information which can be used by the larger public. Okay. The first step is to privatize the data. It has got a number of steps, like you extract from the production system, you convert using the data privacy convert feature. The converted file is then can then be compared with the previous output and seen, and you can see where exactly the data has changed. The converted file is then loaded into the privatized database. Establish the TDM process. The privatized database can then be used to extract a specific portion of the privatized data, and I can insert or load to the testing environment. I can load various environments, whether it is used for application testing or whether it is used for QA testing, or I can have a variety of target environments. I can pick and choose the data which I want to extract from the privatized data, and I can load only a specific portion of information to the various target databases. So how does a typical test data management process look like? Key to the process is there should be a data security team who should be having information about who is in charge, but who is going to lead the data security team, who is going to secure the role-based and function-based authority. Access to the production data is kept to a bare minimum. Access to privatization functions restricted to a privacy administrator. Okay. And the test data creation process is governed by a variety of requirements, like you should be able to define the extract subset. Okay. Larger subsets are required for integration test or volume or stress test, wherein if you are testing only a specific portion of the application for unit testing purpose, you can extract smaller subsets. In many cases, as part of the TDM process, it might not be required to privatize everything, right? So privacy is required only if you are extracting data which is having personal identification information or sensitive data. Okay. So we have an option of optionally privatizing data and extract that specific portion. An edit facility can also be granted for testing of production databases. Okay. So the central process which governs the Optim data privacy solution is the Optim convert process. So the Optim convert process is a process which is responsible for masking, transforming, converting, and privatizing data for testing and security purpose. We can execute this convert process automatically after the extract process, or it can also be done using a standalone convert execution. I can also execute a convert process as part of the insert, update, and load process when I am once I have finished the extract from the production data. Before I load to the target environments, I can initiate the Optim convert. It also has got features wherein I can produce comma-separated values. It's not always required that I am loading the target environment directly. I can even create comma-separated values file, which can be studied by non-technical people. I mean, there might be certain individuals where, for example, business executives who not really are interested to log into the database and see how data has been modified or changed. So they are more comfortable working on Excel files. So I can produce a sample output from the privatized data and store them in Excel sheets and share that with the executive team. The Optim convert process consistently transforms production data for use in QA and the testing environments while maintaining referential integrity and protecting the original data from use for which it was not intended. Okay. So it's very essential that when I'm modifying the data from the production system in the extracted file or the extracted data, I have to ensure that the referential integrity that was existing in the production system is also maintained in the privatized data. Okay? Otherwise, the application logic will fail. So convert processing by default comes with a TDM implementation. So Optim Test Data Management Solution is a separate licensed product, and Optim Data Privacy Solution is a separately licensed product. But certain features of data privacy comes by default as part of a TDM solution. And when additional licenses are purchased for data privacy, you will have additional convert processing features such as keyed lookups, random lookups, hash lookups, aging, currency, and it has got a number of prepackaged lookup tables. So TDM has got certain elementary data privacy features, and if you want more robust and more enterprise level data privacy solution, then you will have to get additional licenses for Optim data privacy. Convert components. As part of the convert request, the access definition or the code which basically governs how the convert will happen is stored in what is called as a table map and a column map. Table map specifies the target and the source tables. Column map specifies the source and the target columns. And you have an option of privatizing only specific columns of a table. I can also use built-in functions for doing this data privacy. And I can also write user exit. User exits are custom code which are written by programmers wherein we want to implement something which is not readily available in Optim. Right? So if you have a custom logic or if you have a specific enterprise requirement which is very unique to your environment, I can write a user exit program using C++ or Java, and I can invoke that procedure using the user exit feature. We would see in this slide how to perform a convert. Okay, so the convert screen, you will have to first create a convert request, wherein you will define how the convert request will basically work. You will create a table map, wherein you map the source and the target tables. You define the column maps, wherein I select particular columns which I need for data privacy. And I edit the source column using a variety of methods, and I can specify the data privacy routines in the source column map. So this is the convert request screen. You specify the source file from where which becomes the source. The source file contains the data which has to be privatized, and the destination file contains the data which will be stored after the privatization. Table map options, you can specify it as a local table map or a named table map. A local table map is something which is very specific to this convert request, whereas a named table map will make it more generic and will make it available to other requests in the Optim environment. I have an option of creating a comma-separated file by selecting that option in the convert request editor. Column map attributes. The column maps basically contain the core of the data privacy solution. Here is where the data privacy actually happens. And all these various Optim objects, whether it's a convert request or an archive request or a table map or a column map, all these are stored in an Optim directory. An Optim directory is a repository. It's like a system catalog wherein it stores information about the Optim environment and will ensure that this information is available to other users based upon how the security credentials are set up. So you'll see how a column map screen looks like. You have the source column names and the destination column names, and you have information about what kind of privacy routines I'm using on the left-hand corner. We have an option of specifying propagate. That's what the first row indicates, PROP. It basically indicates that we are informing in Optim that this particular column has to be propagated, and we are telling that we have to propagate this particular value to all the related child tables wherever this particular column occurs. The source column, I can use a variety of data privacy options, like I can use literals, I can use special registers, I can use expressions, I can use default values, I can even use user exits. That's shown in the 7th row. It says exit PGM name. PGM name is the name of the user exit which has been defined and is available in the Optim exit repository, and I can invoke it from the column map editor. Masking techniques and what kind of functions can be used. So Optim supports data conversion by default. So if there is if by virtue of using a data privacy routine, if it is needed to convert data, Optim by default will be having a specific behavior, like character to character is compatible, character to numeric is compatible, numeric to numeric is also compatible, and numeric to character is also compatible. Okay. In many cases, Optim follows the database data conversion options. So many of the default behaviors will remain the same as in a RDBMS system. Another form of masking technique is expression. I can mask the let's say an address field with a string literal. A string literal is nothing but something which will remain constant for all the rows. So obviously, if I'm using a string literal, it basically means that not everyone, I mean, it's very obvious that all the records of a particular table or a particular data element will remain the same or will have the same masked output. And someone who is looking at the data will know that someone has modified the data. But for purposes of testing and QA purpose, I can very well use a string literal, and that will serve my purpose. I can also use numeric expressions wherein I modify the values using a variety of mathematical operations like addition, subtraction, multiplication, or division. Now the values used in the numeric expression has to be a column name. Other examples of expressions include random or sequential numbers. I can make use of built-in functions like random and sequential, wherein I can specify how the random number is calculated. I can also use a character substrings. The definition of these substrings are pretty much the same as an RDBMS system, wherein I can specify a column name and I can specify the start and the length of the extracted substring. Other examples of expressions include special registers like workstation ID, current SQL ID, the username. I can use these register information and store that in a privatized column. I can also make use of other built-in registers like current timestamp, current date, system date. Optim also has got support for aging functions, specifically in data columns which has got date values, right? Or it can be date of birth, it can even be date of joining, or it can be other examples of date columns. I can use the aging function wherein I can make sure that it's not the same as in the production data. I can age it by a specific day, by a number of months, or by a number of years. Okay, and ensure that when I'm enforcing an aging function, I have to understand the business requirement and ensure that this is as per the business requirement and it supports multiple sets of business rules and hence yields greater accuracy. I can convert currency from one format to another format. Optim also has got support for identity and serial function, which is again very much a basic feature in many of the RDBMS. I can have an identity column which will ensure that every time I insert a particular record, it's going to increment that by a specific value. Some of these features are specific to RDBMS. For example, identity is available only on Sybase and SQL Server, whereas serial is available on Informix database environments. In situations wherein I would like to do some data privacy implementation, wherein I have a set of lookup tables and I would like to make modifications based upon the values existing in a lookup table, I use what is called as the keyed lookup, wherein I specify the source column to be masked, and the lookup table name which has to be searched, and the columns inside the lookup table which will be having the values which is needed for doing the actual masking. Okay. Now for doing now there are a variety of other lookup options also available. I can do a keyed lookup. I can also do a hash lookup. So the differences in these lookup definitions lies in the way the actual lookup happens. So hash lookup will be making use of a hashing algorithm for identifying the hashed value and taking the hash value to get a specific data from the lookup table. As you can see, if I'm using a hashing algorithm, every value that is passed to the hash lookup function would get me an hashing value which maps to a specific sequence number in lookup table, and will accordingly give me a value which can be used for data masking. Propagation, like we have already discussed, propagation is a method wherein we ensure that the referential integrity is maintained across all the related primary and child tables. If I modify a specific value of the primary table, I have, using the propagate function, we ensure that the related child tables across all the various levels also have the same masked value, okay, which will ensure that the referential integrity is not broken at any level, and it's basically mapping to the same, it's having a one-to-one mapping with the production database RI constraints. One important point is that the propagate function should be placed on the column of the first table which is traversed. So if you're having a propagate requirement, we should ensure that the propagate is placed on the very first table from where the traversal basically happens. Traversal is nothing but the place from where the data privacy would start, or it's the starting table. In this slide, you would see what happens without key propagation. So we have the customer's orders in the details table. Now, if I modify the customer's table, and if I'm not modifying the orders at the details table, it would create orphan records, wherein the referential integrity between the customers and orders and the subsequent details is broken because of these orphan records. Okay. When I am doing propagation, when I'm doing key propagation as part of the data privacy implementation, I ensure that the parent, when I'm modifying the parent table, the subsequent child table is also modified, which maintains the referential integrity and would ensure that the application, the QA test cases will not fail. Just to summarize the entire test data management and the data privacy process, data privacy would ensure, entails extracting data from the production database, creating an extract file, using data privacy to create a converted file having data privatized information, using the audit and the compare facility to compare the before and after data. And after the data is compared, and I've got the subsequent compared information, I can use the converted file and load that to the target database. I can use the load or an insert option based upon my requirements and the volume of the information that has to be loaded. The TDM process would optionally contain the data privacy if that is a requirement. If the production database is having sensitive data, if it has to be masked, then data privacy will be part of the TDM process. Else it will be a standalone test data management process. Okay, I can extract test data from the production system, or it can even be from the privatized database which was created in the first step. Once I create the extracted subset, I load it directly to the test database if data privacy is not required. And if I'm extracting from the privatized database, it already has, the extracted file already has got privatized information, and I can load a variety of target environments like the application database or the QA database. I can compare the extracted output from the test database, and I can use the Optim compare facility to compare the before and after images and see what exactly has changed. And if there is a specific unique case, test case which is failing, using the Optim TDM process, I can easily find out what is responsible for the failure of such unit test cases. Okay. So with that, we have finished the this particular discussion on data privacy. We can now take up any questions which you might be having.
Mr. Girish, I've already assigned you some questions. Can you please open up your questions pane and start answering them?
Okay, I could see some questions here. So let me try to answer it in the order in which it was received. So the question is, when we do data masking, data may have alphanumeric, but if I have some field that doesn't support characters, how do we do it? Okay, so the Optim data masking solution or the data privacy solution is not specific to any data type. Okay, so we have got a variety of data masking functions which can be used for character data sets or it can even be used for numeric data sets, or even if it is alphanumeric. I can make use of other data privacy functions like a lookup table. I can understand that if you have got an address field, if I have to use a now address field is definitely alphanumeric, right? It can contain numbers, it can even contain characters, right? So an example of an alphanumeric is an address field, and Optim has got a built-in data privacy function specifically for addresses. Okay. Now there are a number of built-in features which are specifically targeted for certain data types, like addresses for first names and last names, and for social security numbers, for credit card numbers, for zip code. So these are all built-in functions within Optim. If your requirement is something that is not available directly as part of the pre-packaged Optim data privacy solutions, then you have got an option of creating your own lookup tables. You can populate the lookup tables with test data from your own environment, and you can write a user exit program, or you can even use a custom lookup table. You can use that lookup table to use it for data privacy in your own environment. So I hope that satisfies the question that was asked by Mr. Sachin Dixit. The next question that I see on the screen is there any challenges for conversion process currently? Okay, so I don't know what exactly is meant by challenges here. So if now it can be elaborated more clearly, then probably I can answer that. So as far as the challenges are, in terms of the challenges are very specific to specific custom environments, right? So definitely for all Optim implementations, you will have specific challenges surrounding that environment. But then we make use of the built-in features of Optim and then customize it for various customers. The next question, also from the same person, is this compatible with all the environments and other applications? Now again, when I say all the environments and all the applications, again, it's a pretty open-ended statement. So Optim has got support for certain RDBMS environments, and mostly it supports almost all the industry standard RDBMS like Oracle, SQL Server, DB2, Informix, Sybase, Progress. So all the standard industry standard RDBMSs are supported by Optim. And all the operating systems, whether it's Windows or the various flavors of Unix, all these are supported by Optim as well. So I would say that majority of all the pre-packaged applications, whether it is SAP, JD Edwards, PeopleSoft, and custom applications, all these are supported. And you can look up the IBM website and find out the supported versions and the supported environments for Optim. It has got wide-ranging support for all the industry standard solutions that we have right now. The next question is, does IBM have any competitors for this kind of masking techniques? The answer is yes. So there are other players as well in the data masking field. But as far as the Forrester research is concerned, IBM stands on the top quadrant as far as the data privacy market is concerned. So the market leader is undoubtedly IBM data privacy solution, but definitely there are other competitors that we have right now. Can this be used for privacy preserved data publishing? I don't think I understand this question very clearly. So if Parvati, if you can rewrite this query again, then probably we'll try to answer this. I don't quite understand what exactly you meant by preserved data publishing. So going for the next question from Madhavi, it says for a 200 GB database, how much time does it take to create test data? Okay. I won't be able to give an exact number right now, but there are before we even start the Optim implementation process, we follow what is called as the Optim implementation methodology, and part of this process is to understand the requirements, and based upon the database which will be analyzed and the service level agreements which the customer has to fulfill, we would recommend a specific configuration, both in terms of hardware and software. So the time required for performing a particular task within Optim, for creating the data privacy using the various features within Optim would depend upon the infrastructure that is available. Now, this infrastructure is given as part of the recommendations during the sizing phase, the sizing and estimation phase. So it's really very hard to say how much time does it take to privatize a 200 GB database. It depends upon the environment that is made available to Optim. So as far as the processing speed is concerned, just to give you a fair idea, for certain customers, we have archived around 15 terabytes plus database, 15 terabytes plus information in less than 12 hours. So you can imagine how much data can be processed within Optim for a large-scale enterprise environment. Okay. The next question that I could see here is from Vimal. It says, can we get a masking tutorial on the website? Okay. So sure, yes. So if Vimal, if you can go to the IBM.com and search for Optim demo, there are a number of tutorials available on the website. There are a lot of developer work articles also available, wherein we walk you through the process of how data masking is done. And apart from this, IBM also has got education services wherein you can enroll for specific programs on Optim. The next question is this tool only for RDBMS? From Sachin. Okay. No. So Optim has got Optim can read from a flat file as well as from an RDBMS. So I can use Optim in environments which is both RDBMS as well as non-RDBMS. I can read from an RDBMS source and can create an extracted flat file. I can read from a flat file and store that after extraction into an RDBMS. So it is cross-compatible. The next question from Ashim Bose is, it says, will it support all SQL statements? How to avoid null? I don't, when you say it support, whether it will support all SQL statements. So if I understand your question correctly, maybe you're talking about the convert request wherein you want to specify a specific selection criteria. So the answer is yes. When I'm creating an Optim convert request or when I'm creating an Optim archive request, there is an option available wherein I can write SQL and I can govern how many data from the database, from a specific database table is considered for doing the data privacy. So I can create a subset of data from the actual production source. So SQL is one of the supported options. How to avoid null? So when I'm writing a SQL itself, I have an option of specifying that do not select any data which is null. So I hope that satisfies the question that Ashim has. The next question is from Vimal Pandey. It says, what is the maximum size of what? I don't really understand what exactly is meant here. I would just take some guesses. If what you meant was the maximum size of the records which can be archived, it's around 2 billion minus 1. So that's the size of an archive file or an extract file. That means a number of records can be stored in a particular archive file or an extract file in Optim. Okay. The next question from Santosh, it says, what happens if the content of the file is very large? Will it give performance hurdles? Okay. Okay, as I have mentioned, the maximum number of records that can be stored in an Optim file, whether it's an extract file or an archive file, is 2 billion minus 1. So there are absolutely no performance issues from the Optim side. So as long as your operating system can support large file sizes, there is absolutely no problems there.
Well, thanks for the insightful presentation, Mr. Girish. Those were the only questions we had. I'm really thankful to you for conducting this webinar. It was a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this session would be available on techgeek.com by evening. Thank you all. Have a great evening.
Thank you. Bye-bye.